Yes.
Yeah,
And
you
here?
can do a
Yes.
full screen.
Well, it's not for a 1 hour session. Tomorrow morning. Okay, I think we should start. So it's a great project to introduce Rene. Rene Aid is from Dauphine in Paris, University of Dauphine. He's a friend from a long time. We have been working together. We have many papers together. So Rene is originally an applied mathematician. He was head of research group at EDF, the industry company in France. How many people were you supervising? 120. Wow. Yeah. And then decided to go back to it in the economics department. And we did lots of projects together. A chair with EDF, chairs with other things. We had a lot of fun, right? We even have to together. Yes, we have. Yeah. So it's a great pleasure to give you the floor. Thank you, Lori. Thanks. I have my. So I think that. Ready? So now we can see him. So yes, I'm yes, so it's good. Okay. Good. Okay, so I've been doing my job for a very long time, and yes, we did a lot of things together. The research, administration, and development software together. And I think that one of them, and that to be here and why I'm very honored to be here to this place. It's been a long time since I've not been in the US. I've been to Chicago, but not to New York. But I think that you will not complain about that. So I picked. This is a seminar on finance. So I picked the topic about the subject that I've been working on for some time, and I'm still developing activity for that. It's about intraday electricity markets. Okay, so I'm going to talk about that. Okay, and it's a joint work with with at University of Bologna and with at University of Paris. And feel free to interrupt, ask questions, and have coffee and fruits. Okay, so let's see if it works. Yes, so first I'm going to implications about why I'm doing that. Basically, it's going to be your introduction curiosity. Yeah, I'm going to describe the market. And in fact, it's a very interesting type of market already. We can do a lot of things, there are a lot of data available, and we can ask and answer a lot of questions. And then I will present over there, and we give the results which are interesting about market with condition shocks or without condition shocks. There is one where we are very good news, and other we have good news, but less good news. And that's our perspective. Okay. So what are the motivations of this? So what are intraday electricity markets? So there are markets where electricity is being traded for delivery for the next 36 hours. Okay, so in fact, there are in the US, if I take the example of the US, depending on the state, either it's a regulated monopoly or there are markets like in California or here in PGA and stuff. And so depending on the regulation mechanism, that in Europe, it is, I would say, fully decentralized and fully regularized markets where people can pick their electricity provider. And so there are many players, and all those players, for instance, it might happen that they don't own any assets. Okay, they only sell electricity to customers like me, but in fact they buy electricity on the market to make the equilibrium between what their consumers are consuming and what they want on the market. Okay, and so they have to monitor the imbalance. So the difference between what their consumers are going to consume and what they are really owed. Okay, and so this mechanism, this intraday electricity market, are done after the day-ahead market, which is an auction where people set up a certain price, going to show examples, and then they enter a method where they try to adjust very precisely the load curve of their customer together with their production plus their goods. players, producers, etc., they trade to adjust their position between production and consumption. And they do that on a continuous time basis. So every time they have new information, then they change. And so those markets, they act as forward markets for delivering a very short maturity. So you know, all future markets are 10 years markets, and it's so but it has the same mechanism. Every people are trading for every hour for the next 30 hours.
Now, the question is, yes, a very simple question. If I buy this contract, does that mean that I draw the electricity at a level rate for the next 36 hours? Is that correct? Do I think it correctly? There's some uncertainty in, if I buy this thing,
You buy 1 hour for a given hour, and it's written on a paper, just like the future.
but since it's 36 hours, does that mean that the rate at which I'm drawing the power is that's predetermined in the contract?
Yeah.
It's like same amount every hour, or is it?
No, it depends on what you trade. It's like paying, so the hours are for you, they have a number, and so you are buying potatoes, which are kilowatt hours, for this amount, for this hour. Exactly. And then you are being delivered kilowatt hours of electricity, just like it was potatoes.
So it's like something, a sequence of bulk futures contracts.
Exactly.
Right?
Exactly.
Very different there.
It's a forward curve. You exactly have a forward curve of all the pricing for the next year.
36 hours.
But it's not exactly a forward curve I'm going to explain. Okay, so all players, they have special, they are declared as balancing response. So this is an important fact because I can start my own company on Aid.com and I can buy and sell electricity on those markets, even if I have no asset and no customer. Okay, but then I will be charged on my imbalances. For example, there is one trade that I can do is simply to sell some electricity that I will never produce. Because I decide that I will pay in balance. But I have found someone at a certain time who is going to buy my electricity at a very high price, and then the imbalance price is going to be lower. So I'm going to make it. So it's possible to do those type of things. They are very risky, but I can do those kind of things. Okay. If it is a market for specialists. So what does it mean? The translation in French, it means that there are no people. For example, I buy stocks, I buy stocks, wrong stocks, okay? Because I read papers, they are going to have a lot of income, but then yes. Suddenly I am a specialist of the banking system and on the value of banks, and so I buy stocks on that, and then I lose money. Okay, so in this market, there are no people like that. All those people who are currently in this market, there are people who are either producers, retailers, or traders with certain guarantees, and so they know how these markets work. And it's all around in France, for example, the Intraday market is about 800 players per day. Okay, so it's a very small amount of people who know what is happening on this market. There are not people like me buying stuff. Oh, yes, it's going to increase. Okay. So the hypothesis for rationality of players is highly suspect. So normally those guys, they are at least a master in economics and power systems management, and some PhD. Okay, so they do optimization, and there was a significant development of this market because of renewable energy. And so because there is a lot of renewable energy which is very intermittent, then they have people have to adjust on a very short time scale their portfolio. And so 10 years ago, this market nobody was okay, it was okay, but 10 years after, the 10 times multiplication of credit unit or whatever, 10% of the day, lots of time. But it's not that much more, but it raised like this exponentially. Okay? And in fact, there's a lot of volume which is transferred from the stock market to this market because people wait to have the right amount of information. I'm going to show you the movie because I know that you like that in the US. Okay. Okay. So a movie, and it is a movie, and it's a movie done by one of my former PhD students, Pierre. So you see, it's abstract painting. So this one is, it was April the 3rd, 2014. This one is the day, and this one is the time. And this red line is the present time. It is now. Okay? And this red curve, like this, is the spot price that was determined the day before. So people traded on induction, and they decided to trade at those prices between 20 and 60 euro per megawatt hour. Okay? Okay, so the time is going by. This one is midnight. Then we are the second, and tomorrow is the third. Okay? Okay, yeah. And each time you're going to see a blue dot, it is a transaction. Because in intraday market, it's not auction, it is order book. It is an order book, and people put order and they click on order. Okay. And so I let the movie go, and I'm going to see if it works. Okay, because okay, voilà, off, voilà. And so you see that blue dots appear at the beginning of the curve and some way, and they trade near the spot price. It makes sense because the spot price the day before was the best forecast. But then it might happen that some people are going to see this one now is the past. We're going to see here, there are going to be a flyway. If it is the same movie, okay? Yeah, voilà. No, it's not flyway. It's voilà. So this guy bought at 140, then it decreases. Okay, so there were a small amount of transactions that appeared at 120 and then it decreased. And so people are trading all the hours, but they are trading the hours when it is midnight. They are starting to trade these ones, but they wait something like 6 hours before really trading intensively. Okay? And the reason for that is information. They need information. Okay, to see. They need information and precise information about renewable energy generation, which depends on wind, the temperature, and the forecast of their flows. Okay. And so the idea was saying, can we model this? Okay, we always do very ambitious project. Okay, and this one is another picture still from Thomas Deschamps, who was at EDF and Jeff Goulet. They study also intraday, and they modelize intraday prices with both processes. And so when you see here, it's 3 delivery hours of the same day. 6 p.m., 7 p.m., 8 p.m. You see this, and when it is flat, it means that there were no transaction in this period of time. There was one transaction here, and the next transaction is there. And then there is transaction, and you see that this is 3 p.m., midnight, delivery is there. Okay? And you see it's not a long time before delivery, so at 3 p.m. to deliver the next day at 6 p.m. There's not so much activity, but when you get closer to delivery, there's a lot of activity. And this is
looking at, let's say, a fixed calendar date futures contract,
yes,
just looking at the price.
exactly.
As I approach.
Exactly.
Fixed calendar.
Fixed calendar. I look at the delivery. Fixed calendar.
So today, let's say, right, so today at 3 p.m.
Yes.
There's a price for 1 hour of electricity at 6 p.m.
The next day.
Okay, so in 30 minutes, there's also a price for the
Yes.
same time the next day.
Same time next day.
Tracking that.
Exactly. Exactly. This is
And it's getting more volatile as you get closer to, it's like futures, like oil, right?
exactly.
Oil.
Like oil, like many commodities. You get closer to maturity.
You
will. And here, what is very nice, that you do that in the time span of, I don't know, 18 and 3 in 20 hours. In 20 hours, you have all the history of oil market that you buy in Canada, delivering 5 years, and then you wait, and you see 8 and 6 hours, very quick. Okay. So I would like to modelize that and to understand. I don't do aux processes. So there are a lot of other things. So the first driver of this research was to determine optimal trading strategy. Okay, the first one. and the coordination with generation. And the other one was to see if it was possible to determine the price volatility as a function of the flow of information. The thing is, in those markets, the flow of information is highly fluid. It means that there are a lot of regulation in this market because it's going to be very like this. And so every information is put in the market. So whatever happens, the temperature forecast, the wind forecast, all the outages of power plants are reported to the market players. And so there's a lot of information in that. And so it's possible to take that into account. So I will leave because Peter is not there, Pierre is not there, Ian is not there, and all those are not there. So I will skip, unless if you worked on that. Okay, so the results, because I work in an economic department, so I have to state the results, so I have a chance to state them. But you're very nice people, so you let me talk. So first, we prove existence and uniqueness of the equilibrium that in our model. So it works. And with that condition struck, we can find a close form expression for the equilibrium price and for the trading strategy. And in fact, they are very nice because they fit perfectly what people do in trading based in intraday system. It's really simple. If you have to do this job, you would do that in a more sophisticated way, but you would do exactly that, what you want to do. And also there's something we are going to consider, we're going to give the necessary condition for heterogeneity for the price volatility to be increasing for sure. Okay, and so our model will not be a unified model, it will be an N agent model, finite model. And we are tracking this specific type of behavior, and in fact we need heterogeneity. And we have sufficient condition of heterogeneity. And in this case, when there are no condition shock, the volatility is going to be deterministic. Going to be a deterministic function type, it's not going to be very nice. But with position shock, the volatility is going to be stochastic. No longer, but we don't have an analytical and closed form expression anymore. Okay? So we have to resolve either numerical approximation, but we're going to show you that in this case, even with an approximation of things as a small case, we really have the equilibrium price really look like the processes that you are now. Okay. So I don't know how much time I have, 2 days, I think, something like that. Nizar told me that you work late, so there are no problems. And you have no transportation issues, so no transport issues, so okay. And there is food. So and there is food and coffee, so you can say. So the model is the following. The model is the following. So it's N agent. And there is only exactly the same one maturity, and I'm going to track the price for this maturity. Only one maturity. And I'm going to track this price for this delivery period from 0 to 30. And each agent has a demand to satisfy. Okay? D at time 30. He has an initial forecast, Ti0, which is clear. And we're going to consider that there is a continuously updated forecast. Okay? Constantly, in fact, this one is true. In fact, it's every hour. Big players that receive new information on weather forecast, and they update their demand forecast. Okay? And so we are going to assume that there is a common noise. Everyone is affected, for instance, by temperature, and there is a hydroclastic noise. Everyone has specific as. And we're going to assume that the volatility function is going to be there. It's going to be deterministic. This is the thing that we can handle. And it's going to be, as I get closer to delivery, I have more information. So the uncertainty is decreasing, but it's never zero. It might be never zero. Okay? And in fact, this one is true because even when you get to delivery, there is still an uncertainty because you don't have real-time measure of the load of the consumption of all your customers. Okay, so if I have a customer, I don't know, I will know exactly what he has consumed 2 days, 3 days. In the best case, the next day. In the worst case, the next year. Okay. So this one is the demand part, and you see it's the updated forecast is Gaussian. And this is an hypothesis that is very current in our system. Demand forecast the demand evolves like this, like the Gaussian variable you have because of aggregation of small individuals. But for production, it is another story. For generation, the capacity has an instantaneous mobilization at terminal time. So this is an approximation. So I assume that I have a go with a gas fire plant, which is very quick, and I will start my gas fire plant at terminal time to compensate the energy that is lacking to satisfy my demand. Okay? Or I will sell its power to someone who wants to buy it. Okay? And it's instantaneous, no delay, rien. Nothing. Okay? So, and the marginal cost is going to be this one, it is in blue, so it means it's a parameter. And this guy is going to be random. It's going to be random, and it's going to be a continuous time finite state Markov chain. So at each instant, my power plant is in a certain state, and which gives me a certain cost of production. Okay, or like this. But it may go outage, and then my cost will increase, and then maybe it's going to return, my cost will decrease, and so on and so forth. Okay? And there's an intensity matrix in this scheme. So it is complicated. This is why it's a surface around. Because for this one, even for this one, I could not do it myself. Without Julien and Andrea, and with this one, it's not. Okay. Bon. But no computation. I just show the results. I just show the results. And so people, they can trade. They trade in this stuff. So trading inventory of each is like this. So and they trade absolutely continuously. Very simple. They trade at a rate QI. Then you can be positive, negative, buying and selling. And so the objective of each player is going to be something like that. This is the performance criteria, which depends on my trading rates and what I'm going to do with my power plant at terminal time. Okay? And so I would like to minimize the cost of trading. Okay? If Q is positive, then it means I buy. My inventory is going up. I buy power. But there are some transaction costs. Okay? And the transaction cost depends on the ticket. If you're a big player with hundreds of gigawatts of production to consumer, you don't pay the same unit price as a smaller independent producer. Okay? Then if I want to buy electricity in effect, they charge me I don't know. Okay, this one is the production generation, and this one is important because if there was not this term, people would do nothing. And this one is saying that at terminal time, your inventory should be close to your production, to your demand, to the demand, and your inventory plus your production. So it means that you can satisfy your demand either by buying energy, electricity, or by producing yourself. Okay? Or you can do the other way. If I have no demand, I have no customer, but I only have a power plant, I'm going to sell power, Q is going to be negative. Okay, and then at terminal time, I started my power plant, and then I make money. Okay, easy. Okay, well, do you have questions?
Question.
Yes.
Okay, so capital D, little t is what I think the map will be at that specific time.
Exactly.
It's going to up holistically, right?
Exactly.
But I'm confused because capital D is units of actual amount of energy, but is it XT the number of units of the contract?
Yes. It is megawatt. It is megawatt. It is megawatt. Okay? So it is megawatt. This one send unit, this one send
So when is the price of the contract? What's that? That's the price. 1 megawatt. That's the price.
At time T for this delivery at time T.
So I start with capital X sub 0.
Yes.
I'm long that many.
Yes.
Not that many kilowatts already. And I will be delivered on that time tomorrow.
Yes. X 0 can be negative.
Yes, I think
I just think about that.
so I know that, and as what is the best strategy so that when I get to the end,
Exactly.
of course, the answer is going to depend on the evolution of P, of course.
Of course. That's a big problem. Right? Because then this one, if you give me P, I can solve this problem. Okay.
P is not deterministic.
No, it's not going to be. So if you give me P, I will solve this criteria. And And then we're going to define what is an equilibrium. Okay? Okay, so let's see. Alors, and I work a lot. Alors, because the condition is determined at us, we never finish. I think if I go to condition short, so it's okay. Okay. So the optimal generation is something like that. There is a positive part. Okay, because at any time you know exactly the IT, you know exactly the inventory, so you just have to adjust marginal cost of production together with the price Q, and you do something like this. So you get this formula. But this one we don't like it. We don't like the positive part because the positive part makes the problem non-linear mathematics. Okay, so we decided that we're going to skip this. Up, we up, and then we have something like this. So the optimal production at any time can be negative. But thanks to the fact that I'm an economist, I can explain that. It means that at terminal time, if this quantity is negative, it means in fact that sending the signal to people to consume less. Okay, so it's just like demand side management. Okay, so it's just it's an interpretation, it's possible. Okay, so I send the signal and people they reduce their consumption, and so this quantity it's a negative production, it's a reduction of consumption. Okay, so I can add negative production. And thanks to that, the criteria can be brought back to this linear, to this quadratic problem. Here it's quadratic in Q, linear in P, and here we have a terminal condition where here you have a state variable, a second state variable. It's quadratic, but the condition which is before it is random. This one is random, and it follows a Markov chain. And so, in fact, it means that the terminal marginal cost to satisfy your demand is random. Okay. And this one was difficult. And so now what is the equilibrium and how P, the price, is being determined. So everyone, if you give me an exogenous process, capital P, people are going to solve their criteria. They are going to find the best response. Q hat I for P, and we're going to say that we have an equilibrium if for this period P it is the supremum, and if the market clears at any instant. So this one is very standard. So if I buy some electricity, it means that somebody is sold it. Okay, so very basic. And now the questions. Good. How to move? Yes. The futures contract, are there options on what? Are these considered to be futures contract? No, they are considered. I don't want to say spot because they are considered deliveries. Okay, it is physical. Yeah, it is physical. It is considered physical, and it's not considered like a financial product. This is maybe the question. From the legal point of view, these ones are not classified as financial products. They are considered like adjustment markets where you really need to balance your portfolio, and they are considered like exactly I'm trading pure electricity. And so this is why the thing that I told about the fact that I can sell 1 megawatt hour and never buy it and never produce it. This one is tracked by the transmission system operators. They don't like to go to do that. Selling something that you never going to produce in time. Okay.
Can you remind me again the definition of X versus X?
It is inventory.
Controlled by
Q. Yes. You're going to see that. Okay, you're going to see things that you recognize. Okay, so it's a lot. It's a lot, in fact. Okay. So market equilibrium. After 3 years of computations and 2 years of COVID, which is very propice for computation at home. Okay. So Yulian and Andrea came with stuff, and then I did some cleaning, and without production shock, in fact, the equilibrium is very simple. We put structure in the model, so now there is no the market chain. There is no market chain. So at time zero, you know exactly your marginal cost, and it's not going to change. This is why I call no condition shock. the Markov chain is constant. Okay? You know the marginal cost is not going to change. And so, our first equilibrium price, you see that, nice formula. All the pi of t, they are functions which are positive, and they sum up to 1 at each instant. Okay, so these guys are weights. So these are weights. Okay. So this one is a convex combination of what? This one is a convex combination of marginal costs. T prime of I. It is the marginal cost of each producer. But the marginal cost taken at which point? C at I. What is this guy? This guy is exactly the amount that seen from time t, I should produce at time capital T. Look, TIT is exactly my forecast of T1. And this guy is exactly my inventory. This is what I mean. And so this quantity times this guy is exactly the quantity that I forecast that I should produce at time t.
X little t is how much I have now.
Exactly.
DT is my forecast, how much I'll need.
That will be.
Basically, right? At that capital.
Exactly. Alors, this form is because we took linear quadratic models. But in the market, people forecast the price exactly like that. What do? They say, where is the demand? The forecast of the demand. Where is now the cost curve for the next hour? They say it is here. So the marginal cost is here. But it's more complicated because you have constraints on capacities, a lot of constraints like that. We don't have that. So thanks to the fact that we eliminated all these difficulties, we have something which is very simple, which is linear.
What was theta I?
Theta I, this one is it's a parameter of how much you penalize your imbalance. Theta I, how much you penalize your imbalance, and gamma I is how much you pay as transaction cost. And EI is the value of the Markov chain. Okay? EI is going to be the value of the Markov chain. It is BI at time 0. And it does not change. You know it.
So why did you add the value of Markov chain to theta I?
Alors, because it is the same unit. It is the same unit. I don't know, but it is the same unit. I guarantee. You could make things. Okay, look, you could see that very easily here, because here you multiply megawatt to the square, and here you multiply megawatt to the square. Okay, beta I multiplies beta I to the square, and this one multiplies also megawatts to the square. So they have the same dimensionality.
Where is EI in the equation?
Alors, EI in the equations is going to be here. Beta I of capital T is going to move across time, and at time 0, it is EI.
Where is the curvature of the cost?
Yes. Okay. It is the curvature or the slope of the marginal cost. And in fact, in our model, the only thing that moves is the slope of the marginal cost. Okay. It is even like this, it is complicated. Okay, but this one is nice because it is linear, it is things which is very interpretable. And one consequence of that is the trading strategy a kid could play it. What is the optimal trading strategy? You compare two quantities, two numbers, the market price to your forecasted marginal cost. If my forecasted marginal cost is higher than the market price, this quantity is going to be positive, it means I should buy. Why should I buy? Because in fact, my marginal cost is higher than the price, so it's better to buy in the market. But if my marginal cost is lower than the price, I should sell. So we retrieve exactly the type of strategy that people play. They are exactly doing this. Each time there is new information on the market, they redo the assessment of their marginal cost. Okay, and then they do that. But in a more sophisticated way. Okay, they have constraints. Okay. Okay. Do you have questions? No? So when I work, I don't, this one, I put it here, huh? So if you don't mind, okay? I think that there is a question. Is there link for simulation just shown? The slides will be available. Okay? Okay, okay. C'est ça. Hein? Bon, je vais. Okay. Alors, now I'm interested in alors, yes, okay, but consequences. Yes.
How much? But you also, in the little DT, you also produce it.
Yes.
Maybe. Let you have more than.
It's possible that from the time you produce. It's possible.
It's not the whole time though. Like, equity is how much I'm trading the contract.
Yes.
And so now the units got to go up.
Yes.
But you said also during this time period, you also producing
No.
as well?
No, we're not producing this model. We are going to produce only at the moment.
Only at the end.
Only at the end.
Oh, I see, okay.
Only at the end. So I need instantaneous.
No storage.
No storage, nothing. You cannot store. There's no battery. There's a lot of no battery, no storage, no dynamic constraints.
But like you're deciding today you're gonna produce at that time capital T.
No, you can arrive at time capital T and then decide based on the observation of the demand capital T and your inventory capital X and the price.
Multiplies which
And then you make your optimal decision.
Thank you.
Okay, so this one is good. I check. Oh, I'm on time. Voilà, ça c'est bien. Alors, now the volatility. Alors, first also, let's say the price is a martingale. Okay, and then the closest form expression. So it's normal that the price is martingale if you look at the area. It's normal. And so, in fact, we have the expression of the volatility of the price, which depends on all the noises of everyone. And you have an expression for the quadratic variation of the price. You have something like this. It looks complicated, but let's look at it. Alors, first, if all agents were the same and sharing the same also correlation, if the correlation was 0, so no common noise, then the mean field, the volatility will disappear. Okay, this is normal. This is the law of large numbers or something like this. Okay, there are a lot of people, they are all independent, and then you make the number of people go to infinity, so the price is going to be determined. And it's going to be completely flat equal to the current initial price. Okay, so this one is not spectacular. Okay. But now something which is nice, I find nice, it is this one. If we assume that the volatility functions of the forecast are decreasing, and if you look at the forms of the FI, because they form a convex combination, it cannot hold that they are all the same monotonicity, because they have to sum up to 1. Okay? So if all agents are identical, same parameters, really same parameters for everything, then in fact all the FI are equal to 1 over n, and the volatility has an expression like this. And if the volatility has an expression like this, then the volatility is going to decrease as I get closer to maturity, which is exactly the opposite of what we observe. So it means that in this model, because we have a lot of questions about that, of course, it is in this model making if I want to add the Samuelson effect in this model, I have no other choice than to say that agents are not identical. They need to have some difference. There need to be some heterogeneity. But which one? So there's a lot, because there's a lot of parameters. So this is why it took time, because I tested a lot of them. And so we found 2 cases where, in fact, we don't have the necessary exception condition. We just have, it's necessary that there is heterogeneity, but it's not sufficient. I can provide example where I take people which are different, with different types of parameters, and nevertheless, I get the volatility which is detailed. Okay? But there are 2 cases where we say these ones are respected, and it is true. Market acceptance quality is heterogeneous. So the only thing that differentiates people is the fact that some guys pay a lot and some others pay little their access to the market. And then, boom, we're going to have some reason. Another case where it holds true, it is everyone has the same market quality, but they have different production costs. And then again, you will have a solution. Yes, question. The fact that the volatility is increasing when you get closer to maturity. It is a standardized fact of commodity market that we observe in many markets, but not all, and for which there is a literature which is very vast. Just to explain, at the least cost, at the least possible cost, why is this phenomenon occurring? And so in this case, it is so this is nice. Now, production shocks. I am on time. So this one, we only have existence and uniqueness reasons. So no closed form expression for the general case. This one is still an ongoing project. Okay, I do hope that my collaborators are going to have some illumination and find a way to solve the backwards that gives the result, but they don't. So the only thing that I can show is a small case where you assume that there is no demand uncertainty. So the forecasts are perfect. Okay, and by that was the view in the paper. So you assume that you know your demand, and the only thing that you're going to face is uncertainty on your production or on your production cost function. Okay? And I reduce also the number of states of your market chain. There are only two states, either good or bad. Okay? And G stands for good and B stands for bad. Okay? And so you have a population and there's a market chain and there's intensity. And so there's intensity height of switching, I never know of these guys, but it is a matrix like this. Okay, and those numbers are fixed equality. And you assume that the population is divided into two types, type 1 and type 2. Okay, so I took in the simulation, I would take 100 people of one type, 100 people of the other type. Okay? And they're going to be like this. And let's see what it gives. In this case, alors, bon, yes, it is important. It is important, but okay. So in fact, there are two equations that are important. It is some ordinary differential equations. We're going to drive, in fact, the behavior of the optimal trading strategy. Either you're going to be in a good state or you're going to be in the bad state. This one is going to be something like your marginal cost of one parameter at terminal time. Okay. Either if you're in the state good, it's going to be this one. If you're in the state bad, you're going to be this one. And in fact, you're going to, when time is going to go bad, your Markov chain is going to be either on this equation or on this equation. Okay, so it's going to switch from following this curve, I'm going to call that, or following this curve. Okay, I'm going to show that. No, don't worry, don't worry. Voilà. Pictures. So, you have two types in red. I start with the blue guy. The blue guy, there are those two equations. You see, yi and yi good and yi bad. Yi bad is this one, which is higher than this one. So it means that the guys in the first population, basically their marginal cost is going to follow these two curves. And they are going to move and switch from the dotted curve to the plane curve, randomly, depending on the jumps of the Markov chain. Okay? And for the blue population, what is happening is that when they switch, when they move, they don't vary much. Okay? But what happens to the people who are in the red population? For the people in the red population, at the beginning, when they switch from good to bad, nothing changes really. But when they get closer to maturity, they can either go very good meaning very good, but their marginal cost is going to be much less than the blue population, or they can go very bad with their marginal cost going above the marginal cost of the blue population. So if I start at time 0 and I'm here and I'm red, what I'm going to do is that I'm going to sell. Okay, because my marginal cost is below this guy. Okay, so I'm more efficient than the blue guy, so I sell power to the blue guy. Okay, and as time goes by, I may switch from, but then suddenly, when I get close to 8, if I jump here, then my forecast on the price is going to be there. So I'm going to switch from being much efficient than my competitors to much less efficient. And so the behavior is mechanical. In this case, what I'm going to do, so there are numbers equation, June to impress you. Okay, so you know that you were right to invite me. Okay, and so this thing, so the trading, this one is the trading activity, the absolute value. So during a very long time, you do nothing. And then when you get close to maturity, then you adjust and you have to trade a lot. Okay? And the price, alors this is a simulation. Look, this is the proof by the eye. Okay, I have no other proof. Look at that. On the right is the recall of the picture that I showed you at the beginning of the talk. And on the left, it is one simulation with a two population of 100 customers or 100 agents, one with good population, one with the other. And so during a long time, we do nothing when we get close to maturity. And this one, because I learned this word before I come here, just to realize, and there is absolutely no volume part. It is only two jump processes because I simulate only macro chains. But you have 200 macro chains which are independent. Okay. And so some are, so you see, it's very close. But I don't know if this guy, I take this trajectory, I tell to my friends, is it an false positive? And yet no answer. Okay. But I hope I will. Okay, so. Attendez, voilà, ça. Voilà. And perspectives. Alors, first, I'm frustrated because I don't have the exactly explicit formula when the case is jumps. And so, I'm working with two colleagues in Greece to the case where we are going to do the forward curve dynamics. So this one, for you, is going to be not only you are going to trade the maturity capital T, but all the maturity between 0 and capital T, and you're going to do that bilaterally. So we're going to try to do that. It's not it's starting the very slowly. And the last one, it's a very excellent, it's exactly the question I asked some colleagues. Well, is it possible to analyze the trajectories that we produce with this model to say if they exhibit something like an express? At the limit, it is true it is low, because all the macro chains are independent. So there is no way. But for a finite number, so we are trying to see if it's possible that an equilibrium model is going to produce rational for the execution of Fox processes. So I thank you for your attention. If you have questions, I am here. And if all people are connected, I can take questions.
You know, for the previous graph you generated, there was 100 agents, right? How is that changing that parameter?
Alors, if I increase the number of people, pas bien, hein? C'est good, hein? No, mais it was predictable. If I increase the number of players, in fact, the curve, the scale is going to be different. You're always going to see something like this, but in fact, the price is going to be flatter and flatter and flatter. Because all the macro chains are independent, so when I add a lot of people, and because the price is an average of all the behavior, then we go to something which is
And there's no common price.
there is no common. There is no common macro chains in that people jump the certain intensity rate which is the same for everyone. But it is also difficult. We have common knowledge. It's also difficult. And no question is not going to go on.
So for the market participant, you're saying when they're trading, they need like some information, like
Yes.
some time before. That's why I guess the sales effect happens where most of the trading happens before
Exactly.
the maturity.
Yes.
Okay.
And this is bad. Why? Because people can say, yes, don't pay this, because people get excited at the end of the trading period. So, but we have a project. We have a project, very nice project, where in fact, I'm going to get rid of maturity. No maturity. People can trade, nevertheless, experience shock, and then have to adjust their position. Okay? And the phenomenon should occur. So you should see bursts of volatility that disappears. In this period, it is exciting because of two reasons. One guy went from very efficient to very inefficient. And so he has to trade. But others are doing the same way. So I want to trade, but the others also they need to trade. So it is a snowball effect.
So your conclusion is that the volatility is coming from the fact that there are finite number of factors.
My guess here. Alors, it is not exactly the volatility. Meaning that, in fact, what I would like to have is self-excitation. This is what I'm looking for, and yet I have no clues of the fact that these trajectories exhibit something like self-excitation.
How do you define self-excitation?
The fact that some orders produce more orders. Okay, so it means it's like it's a process where the intensity jump depends on all the jumps that occurred before. Okay, so it is something like this. So I tried the specialists on that. They're writing equations, but soon I will have this.
One more question about the number of market participants. What if n goes to infinity? Can you solve the meeting model?
Alors, Peter solve le modèle like this.
Should be easy, right?
Alors, I don't know it. Because I forgot something. No, it's not grave. Yes, it is important. It is important. Look. No, I have to, no, because I skipped one slide, which is important, I forgot. C'est lequel? Ah oui, c'est celui-là. Look. Alors, for your answer, it is possible to solve the NIFTY that Fender did it with volatility where they did one large player and a crowd. But I like better, I like this one, but I don't like it, this one. I have reasons for no, because no. Okay. No. If we could do an NIFTY with common knowledge to understand what is happening and solve it, and one of my own was that concerned with the jump processing, it would solve it. But I did not know at that time that how to do that. And this one is also a feature of the equilibrium price. Because in this trading strategy stuff with market impact, there is always this formula where you have the price can be decomposed into a fundamental component. And this fundamental component does not depend on inventories. And this one is exactly so I can recount the equilibrium price like that. With prices, and this one, the epsilon I are coefficients like this, and which are exactly so. The thing is that you see, if the importer means compared to make an average, then the price is going to be impacted. But one thing which is interesting is so it is exactly the unemployment increase formula. Okay? It is with the market impact which depends on time. Okay, and the permanent impact, and if all agents are identical. All these terms disappear. And you only have that the price is the fundamental price. And this is something that I was wondering. Because if people have all the same market impact, I don't understand why the price should increase when somebody is buying. Because if nobody has the same market impact, I don't understand why the price is moving. Because when you are buying at a certain rate, somebody is selling at the same rate. So because the market is. So it should be the net effect to be zero. But if you have different market impacts, then it makes sense. In cost of the money. Okay. This one.
One question.
Yeah.
For the maturity, you showed 18 hours, 19 hours, and 20 hours. So maybe I'm looking at this wrong, but like, could I make like the weak assumption that the maturity like doesn't matter and only towards the end is when like the trading will happen, regardless if it's 20 hours or 36 hours.
Yes.
Trading will be done, like the majority of the volatility will be like the hours left before.
Exactly. The 6 last hours. Okay. And everything. I think like something like 85% of the trades occur in that period before the it's not isolated trading. Electricity trading in Intraday, it is slow trading. People, it's slow trading. People are, it's not, there are some algorithms, a few starting algorithms, but it's, the liquidity is very limited. The spreads are like that. So you can make a real money on intraday market. In fact, in Europe, it is a trend where people are investing a lot in these markets to trade, because you can make some arbitrage between prices because it's very, very badly arbitrage.
So in the electricity market, it's most like discretionary thing, or
Yes, it's possible. It's possible because they say like this.
more than systematic than strategy.
No. There is more psychological systematic trading.
Like the algorithm.
No. The small algorithm, small amount, and more manual. More
That makes sense.
Yeah.
If you go back to the first time you showed the martingale process of the price.
Which one?
The first time you introduced the martingale process for the price action, all the way back. So we'll go back here, all the way back. Yeah, over there, right. I'm sorry, no. I'm being stupid. What I'm gonna say was, how is that? You can say in a couple words, what is it about this whole system that ultimately says that the volatility of the price at this time? That's what.
This one is the time dependency of the volatility of the forecast. Of the forecast of demand.
I'm sorry. No, okay, but that, when you work out the determinants of, the volatility, that has an impact on where's the dominant effect of that. Of course. Right. Where's the SDE for the price process? If it's embedded.
Yes.
So, right?
Stochastic differential equation for the price process. After long computation, it is here. It is a martingale, which is given here.
All those parameters. Exactly. So you derive the price process dynamics. Yes. From the dynamics of demand. Exactly. It's the other way around, so it's even more. It's not exogenous price process. No, it's only the stuff. It is an equilibrium.
Why is it not?
Alors, it is the martingale, not the frictions. Yes. But because in fact the criteria is an expectation. And if you took first order condition, no jumps for the Markov chain, you would find this one very directly. If there was a trend, in the criteria, if the price here were not martingales, if there was a trend, then you would know that in expectation the price of maturity would be higher. Then you would buy and sell for 1. You would buy at time 0 a lot and sell a lot at every time, then you would make money.
It's a cost function.
Yes, but nevertheless.
I chose the exact amount because of the cost function, you would have like transaction cost, you would have a wedge.
Yes. In fact, we have that exactly somehow pointed me that thing. If you suppress this one, you don't care about this one, you only trade and you look at this one. Then you would take first order condition by differentiating the criteria with respect to Q, and you would find that the price should be expected, the conditional expectation of the marginal cost of the time, so it is marginal. And if it is not, then it is not. And we try, for instance, to put a utility function there. So risk aversion.
In French, it means, I don't know.
It means I ask, you know, that, okay, now this one, now it's another flavor, maybe later. Yes.
Is there any question in the audience, in the Zoom? I see there's something on the Zoom.
Okay, attends. I'm going to take it. Alors, j'arrive pas à lire, it is too small. Ah, yes, it is the link to the paper. Yes.
Okay.
It is the link to the paper.
So if there's no more questions, Okay, so Rene, thank you very much.
Thanks a lot for Alors, I have to stop the sharing and stop the recording.